So the first thing we need to do is connect to our AWS account. And in Terraform, whenever you want to connect to a technology and start using its API to create resources inside, to configure it, to add some stuff, etc., basically just interact with this technology, AWS, Jenkins, a database, whatever it may be, first thing you need is a provider. So provider in Terraform is basically a program or code that knows how to talk to that specific technology. And if we go to Terraform main page in Browse Providers, here you see a list of providers that Terraform has. And as I mentioned previously, Terraform actually works well and integrates with lots of different technologies. And this is basically how Terraform integrates with them using providers. And here you're going to see the list of all the providers Terraform supports for all the different technologies. And this is an interesting part here. First of all, we see the most common used ones. AWS is obviously something that Terraform is widely used for. A very obvious reason for that is because working with AWS through command line or management console is hard because it is so granular and modular and powerful that it's really difficult to work with it manually. So automating AWS makes perfect sense, as well as we have Azure, Google Cloud, Kubernetes, and so on. Now, if we scroll down here, you see a bunch of other providers that are all by HashiCorp, right? So these are basically the providers, again, code program that knows how to talk to that specific technology, right? So this code here is written so that it can talk to Kubernetes, so that you don't have to know how to talk to Kubernetes API. Same goes with AWS. You don't have to know how to talk to AWS API. This provider translates your Terraform configuration to something that AWS API understands, so it can talk to AWS for you. And as I was saying, these are basically a bunch of providers talking to Helm, talking to HTTP, console, lots of different technologies, all maintained and created by HashiCorp. And if I scroll further down, here we have partner providers. And these are third-party technology partners that have created these providers and also actively maintain them. And you also have community providers that are basically created by community members. This could be teams of developers or individual developers that publish their providers to Terraform registry for others to use them as well. This is also a huge list of different technologies, and here it always says who is maintaining it or who is creating. And very logically enough, there are lots of different technologies that also want to be integrated in Terraform. So they create their own providers for their own projects or products so that Terraform users can talk to that API. So we have Artifactory from JFrog itself, because it's the product from them. We have a number of other different providers here that have all created their own providers. And these go on page after page, and the number is going to keep on growing the more Terraform is used. But you also have providers that are just developed by developers or DevOps engineers who want integration with the tool. For example, if we look for Jenkins provider here, we see there are a number of different providers that are developed by different companies or individual engineers. So basically this means that whenever you decide to use Terraform for a specific technology, for example, we want to use Terraform to connect to AWS and create resources inside, you can come here in provider section, you can look up the provider for that technology and start using it. So in this case, we are going to need AWS. We're going to see other providers and how to use them later. Let's actually click inside. And here we have overview, and what's also more important is documentation. So here basically you have a bunch of examples and documentation of how to use the provider. So for example, because Jenkins isn't officially from HashiCorp, again, let's look for one. Let's choose this one, for example. You see the statistics of how much it has been used, which versions, etc. So for example, if we go with this one, we can check the documentation for how to use a provider as well as which resources are available. Now, I want to note here that Terraform is really, really well documented. So whenever you're looking for an example to create, to orchestrate or automate some technology with Terraform, you can actually just look it up here and you will for sure find a documentation for it, as well as do Google search, because they also have all of these very highly search optimized, so you can directly Google all this stuff. For example, if we want to create EC2 instance in Terraform, you can basically search it in Google, and here you get immediately the first result is documentation to how to create AWS instance. So they're very well documented as well as search optimized. So this is actually one of the best things about any technology if they have good documentation, because it makes using that technology way easier when they provide examples and explanation. So we're going to be working a lot with the documentation itself and seeing example usages here. And just so you know, this is not a case with many different technologies. So this is already an advantage that Terraform has. So let's actually close all this and let's go back to our AWS provider documentation. So now let's actually use the AWS provider in our main.tf file. So first, I'm going to open the folder that we created, Terraform folder, so that we have a view of all the files inside that folder. So this is going to be our working directory. And in the main.tf file, we're gonna write following code. First of all, provider, AWS, and you see the syntax highlighting already. And we're gonna pass in configuration that will allow Terraform to connect to our AWS account. So first of all, we're gonna define the region, and you can choose one of the regions from the list right here. So this part is the name of the region, and you should choose the one which is closest to your geographic location. So I'm gonna go with EU Central 1 in my case. And we're going to define our access key and secret key right here. And we're going to hard code it for now. Later, I'm going to show you a best practice of how to actually set the credentials and not having them directly in the code, because Terraform, being an infrastructure as code tool, basically will be used and its files will be checked into a code repository like Git, for example, just like application code. So we don't want the sensitive data hard-coded in there. But for now, we're gonna write it directly here. And these are the access key and secret key of the admin user that we created in our AWS account. And you remember that we downloaded the credentials file for that user. And we have access key and secret key in that credentials file. So we can basically just copy it directly from here. So this is the access key and the secret key. So now using Terraform, we will connect to the AWS programmatically using our admin user with these credentials. Cool, so now we have basically told Terraform with this code that we want to use AWS provider because we are going to be working with AWS. And we're telling Terraform that in order to be able to connect to our AWS account, it will need these credentials. And this is the region that we are working in. So know that AWS is the name of the provider, so it has to be AWS. And you may be wondering where I got these values from and how do I know what these attributes are called. Again, as I told you, you can find all this documented in here. For example, here we see the usage with credentials, access key, and secret key. So you can find the attribute names and all of this in the documentation. Now, as I told you, provider is basically a program. It's a code that knows how to talk to AWS. And when we install Terraform, it doesn't come with this code automatically. A simple reason is that because it has so many providers and you're just going to be using just a handful of them, right? You don't want your Terraform to have all of this included because it's just going to be a lot of wasted resources, right? You're going to need a lot of space, storage for all this code. So instead, it's actually modular. So you as a Terraform user decide, you know what, I want to work with AWS and Kubernetes and maybe Jenkins. So I'm going to install these 3 providers and I'm going to be working only with those 3. So that means that whenever we define a provider here, we need to install that code, right? Because it is currently not available locally, right? You can compare it to the dependencies in programming languages, right? We define dependency inside a build tools main build configuration file, and then we actually need to install that dependency by executing a command of that build tool, right? Like npm install, for example. So the same goes with Terraform. We just need to define which provider we want, and then we install that provider locally. Now, there's one more thing we need to do here. And if we take a look at the official AWS provider documentation, we have a syntax for any Terraform version above 0.13, where we define globally in the Terraform configuration which providers our Terraform project uses, as well as define the version number for each used provider. Now, this is not required because it will work without this code as well. However, it is a good practice to define this explicitly. And if I click on the Use Provider button here, it gives me the actual code with the specific version of that provider, which is always the latest version of that provider. And I can basically copy and use this configuration in my Terraform project. So I'll copy that part, go back to the project where we already have the provider configuration defined, and paste it in here and save. So now if we have multiple providers that we use in our Terraform project, we can actually list all of them here within the required providers block with their specific versions. Another common thing related to this configuration is to create a separate file called providers.tf, for example, and have this configuration defined in this providers file. So now we have defined the AWS provider, we can install this locally using Terraform init command. So let's go back to the editor, and I am in the Terraform folder where main.tf is located. So when I do Terraform init, Terraform will look inside that folder where I'm executing the command in and see that I have defined a provider, so it needs to install it. So, and that's also an important part because as you see, we need to execute this command inside that folder. So it actually matters where we execute Terraform commands for, right? For example, if you have multiple projects with multiple Terraform files, all separate from each other, then you have to go into the one that you want to execute the Terraform commands in. So let's do Terraform init now, and Terraform is going to check for the providers that we have defined in the project folder to initialize the project. And here you see the version number. Because we specified the version in the providers file, Terraform will look for the provider with the same version number and install it in our project. Okay, awesome. This is successfully initialized. And now if we go back to our project folder, here you see we just had main.tf and providers.tf files in that folder. And now we have 2 files that have been generated by Terraform. You can see it here as well in the file explorer. If we do show hidden files, these two got generated. And this is actually a hidden folder. So if we expand it, you see Terraform provider AWS with the version that got installed. So this is actually the code that has been downloaded that will then be talking to AWS for us. So this is the AWS provider code, and this is a file that basically keeps track of which providers are installed locally, which versions we have, and so on. So if we add another provider, then it will appear in here, and another entry will be made in this file. And these are managed by Terraform. We don't do anything in there. And again, if we use multiple providers, basically have them all listed here. And it makes perfect sense, especially if you're using 10 or 20 providers in your project. So you can extract that whole configuration into a separate file to keep your code clean, right? Because this is basically the logic where you provision infrastructure, and this is going to be just the place where you define which providers your project is using with which versions. So you have this separation in your code. And there is one more thing to understand regarding this provider definition. This does actually work without this code as well, and we can actually use the AWS provider without explicitly defining it here. However, it only works for providers which are part of the Terraform registry. So again, if we go back to the documentation, you see that this provider actually is hosted by HashiCorp itself in its official registry. And HashiCorp has a list of official providers which are marked using this icon here. However, there are other providers that are not part of the Terraform registry. And for them, we would actually have to explicitly define this configuration. Why? Because this configuration actually defines the source or the location where Terraform should look for the provider code to download. So we need to tell Terraform, this is the provider and please download it from this location, which in this case for AWS is HashiCorp itself. However, let's see what happens if we try to use a provider which is not in the Terraform registry. Let's say you want to provision infrastructure on Linode platform instead of AWS. And for that, of course, you go to Terraform documentation and you search for a Linode provider, which is a verified provider and not an official one, as you see with the icon here. And let's switch to the documentation and copy the code for using the provider itself. So we have a Linode provider defined. And now if I try to do Terraform init, you see an error message that says failed to query available provider packages. And right here you see that it tries to find a Linode provider in HashiCorp registry. And it says that it doesn't have such a provider in that registry. And that's the error message because Linode provider isn't hosted there. So exactly for that case, we need to explicitly define the source or location of that provider. And again, moving back to the documentation, you see the code of how that can be defined, either here or in the use provider link, where you also get the latest specific version. Copy that, define it here. So now, as you see, Linode isn't in the HashiCorp registry, but in a registry called Linode, and we have a version as well. And now if I do Terraform init again, Terraform will be able to find that Linode provider in the correct location and then download the provider code for this version inside the Terraform project. So if I expand this, now we have Linode provider's code available locally. So that's basically what you need to know about this specific definition of providers. It is optional for official HashiCorp providers, and it is mandatory for non-official ones. However, it is a recommended way of defining providers. So now that we have provider installed locally, what can we do with AWS? Right? How we can interact with AWS using provider? And this is another important and interesting part. Provider actually gives us access to the entire whole API of AWS. So basically, whatever is possible to do with an API of a technology, provider is giving us that possibility. So if AWS exposes different services and resources in those services, then we can interact with all of them using the provider. So through AWS Provider, we actually now have access to every single service in AWS and the resources of those services. So we can do whatever we want in our AWS account. And if we go back to the documentation of provider, of AWS Provider in this case, here you see which resources of AWS are actually exposed and which resources we can work with as a list right here, right? So you have different services and different features. Here you see we have EC2, ECR, all of them listed here. And if I expand this, inside of this service, we have a bunch of resources. So basically we can do whatever we want for EC2 service.